Hola. Okay. Okay, so let's get started because they've already told us that we are a little bit tight on schedule. First of all, thank you very much all for coming here. My name is Izquierdo, and I'm going to talk about disaster recovery, specifically the use cases for big data. But first, of course, let me tell you a little bit about myself and especially my company. I work and I'm founder of a company called Datatons, which has the incredible value of us all being nerds. So we love technology, we love what we do, we're always interested in doing the latest stuff, testing the relevant things that are on the big data market. The three founders started working in big data in international companies, okay, so we were more in consultancy mode, things like that. And at some point, our previous company decided to go on to a more traditional IT route, and we set up our own shop, our own startup, mixing the technical skills that we had and some business skills as well. And well, we're just, gone from 3 people to 12 people right now, and we're working in projects in big data, both big and small. So, disaster recovery. What's disaster recovery? I mean, when we are talking about that, people that come into the big data world, specifically things like Hadoop, they're used to working with distributed systems which have already some kind of built-in resilience. And some people get, this strange notion that basically that's like invincible. You have a cluster that works for everything, will never stop, has no troubles. Well, and sometimes they have told me things like this, like, okay, if I already have things like HDFS replication and high availability built in, why would I need disaster recovery? Some have even gone so far as to say, why would I even need backup? Okay, as you can see, even the most robust systems can fail at some point. So since there's quite a confusion about the different terms here, let me just do a small recap of what it's to be understood from these concepts. So first of all, we have high availability. High availability is a systems issue in the sense that when the tech people build servers and these begin to get some work done and they become important for the business, we then get worried because we know that we are working with electrical systems that are prone to fail at some point, okay? So what do we do? For example, if a disk goes down, we cannot let the whole server go down. If the server goes down, we cannot let the system go down. So we build these redundant layers of hardware that we set up so that when one fails, the next one comes in immediately and takes charge, okay? So basically, high availability comes from at least doubling your components, okay? So it's a more expensive way of setting up things. It's a more complex way of setting up things. I've seen, for example, people fail to see that high available systems are more complex, therefore they cannot be just left in the hands of junior system administrators. And basically what we achieve with this complexity is something that immediately comes into work as soon as something is wrong. The next thing that we would have is backup, okay? I won't go into much detail because we already know what backup is. You make a copy of what you have and you store it and you have a sequence of snapshots in time of generally your data. So backup is more of a data issue. Backup usually protects you from things like I deleted a table, data gets corrupted, or you can even use to check it for tampering modifications, to check the status of something. So responding to the first question, I mean, even if you have high availability, if at some point you delete something, if you don't have backup, well, you have a problem because the other copy of the hardware will also work with the deleted information, so you will not be able to retrieve that. And the last thing that I want to mention is that basically backup takes some time to restore. So you could use it as some high availability in the sense that, well, you can restore functioning from a backup, but it will take a lot of time, specifically when we're talking about big data. So finally, we get to disaster recovery. So what's disaster recovery? Everybody thinks about things like, okay, nuclear bombs, terrorist attacks, something like the 11th of September, something, but you don't have to have such a big deal to resort to disaster recovery, okay? Disaster recovery protects you from data center problems. So, and it's also a business issue in the sense that not only IT gets affected. I mean, there are specific procedures for having disaster recovery in the case of information, of administrative issues. So it involves a whole more people in the company. As you can see, it will protect you from things like small floods, fires, power outages. I mean, this situation is real in the sense that you may have just a broken pipe and you know, your highly available server, Hadoop cluster, with all your redundancy built in, is flooded now, and you cannot use it. So you need somewhere else to work. It's basically similar to what you have in insurance. So, I mean, you cover the same kind of problems. And it takes, let's say, a medium amount of time in the sense that we did say that high availability was immediate, backup takes a lot of time, and disaster recovery takes something in between. So you generally have to do some manual things, so it will be in the order maybe of minutes, maybe of hours, few hours, but it will take some time to come into place. Okay, so we want to do disaster recovery, we want to cover ourselves from these kind of problems. What are our options? First of all, we have to need to build a second data center, the disaster recovery side. Ideally, that would be an exact copy of the first data center. I mean, you just take whatever hardware you have in the first one, you build on the second one, and voila, you have disaster recovery. And of course, you want to make sure that all the data is exactly the same, that the secondary side, the backup, the disaster recovery side works with the same performance. However, this is often really expensive, so you don't want to double your IT costs just for setting up disaster recovery. So what do you do? What do you do to have something that's, okay, not cheap? Disaster recovery is never a cheap solution, but something that's, okay, affordable, cheapish. First of all, you need to take into consideration certain aspects, okay? First of all, we said that this was a business issue, okay? So you have a service, how much would the having a downtime in that service cost for the company, okay? So that's the point where you begin to have a disaster recovery. So maybe some services are, not important enough to be in the disaster recovery procedures. Second, is all information equally important? I mean, you certainly have business transactions that you don't want to miss even a single one, but maybe you have some information that it's not so important, or it can be constructed or deducted from others. So maybe if you lose part of that, you're able to recover from that. Also, we said that you had backup, and maybe you can recover data from backup if the information is not critical enough to, you need it like right now. You may need it, let's say, a couple of weeks after. Maybe you can wait until the backup gets restored. And finally, of course, also you need to check if, okay, I've left a pile of hardware, very expensive hardware, sitting there. Can I do something else with that? Also, where do you place your data center, your secondary data center? First of all, you have to check availability. I mean, if you already have some offices elsewhere, they're probably a good option to, build some kind of recovery site there. Also, latency. I mean, depending on where they are, the connection they have, they may not be suitable, or they may be, so you have to check that. And finally, very important because it gets overlooked sometimes and then problems come, you have to take into account legal considerations. Let's say, for example, that you have offices here in Europe and offices in the US, and you work with personal data. I mean, so you have information about your clients. That's sensitive information. And you say, okay, I want to build a disaster recovery. Why don't we just copy all the data that we have here to the US and vice versa? Voila, you have disaster recovery. Well, your legal department will tell you that you can't. okay? There are different privacy policies here and there, so maybe you cannot move the data, okay? Even if you can technically. Another important aspect, and it's related to this information flow or the level of consistency that the two data centers need to have, is the synchronicity, okay? When you do asynchronous data replication, it means that every transaction gets replicated on both data centers, so you have the exact same information every time, okay? You do not miss anything. However, of course, that requires quite an amount of effort. It will require probably very specific connections, network connections and things like that. So depending on where the site is located, you may not be able to do so. Whereas asynchronous is something more like the photo down, which is just people queue up. Eventually they get on a train, and the train arrives to its destination, but it doesn't need to be at a specific time. So you'll eventually get there. It converges, okay? So it's more resilient to things like delays and things like that. And it's generally cheaper to build an asynchronous solution than a synchronous one. Okay, so we have big data. What's the problem with big data, or why are we talking about big data here in relation to disaster recovery? Why can't you, if the company already has a disaster recovery policy, why cannot we use the solution that's already implemented? Well, first of all, given the amount of data, it might not be possible to just copy synchronously the data, okay? It may be because of the network throughput, or it may be because of one very important thing, which is that generally big data clusters do not have central storage. So you cannot just rely on the cabin, storage cabin, to just copy the data from one place to the other, okay? So you have to do something different. Also, these are generally physical machines, okay? So that you cannot use either the replication that you would use with virtual machines. You just, copy everything, or make sure that everything can be just started on the recovery side at some point without troubles, okay? So you have to, these are the things that make it different. However, of course, all the other general rules apply. It impacts users, so you have to take into consideration if there have to be changes done on one place or the other. You have some DNS and network changes that need to be taken into account as well. So, I mean, both clusters, both in the main side and the recovery side, need to take that into account. And of course, any big data cluster, or basically any platform in the IT infrastructure, is never alone. It's not like you have a system that's outside everything. It generally depends on things like authentication. You may have some LDAP, some Kerberos, Active Directory, whatever. You probably need some relational databases for storing the Hive metastore or things like that. And you may have even some virtual machines that are some gateways. So all of these, you probably need to put into the general procedure for disaster recovery, but you need to make sure that all systems can respond to that. So, given that, what are our options? I mean, we said that we had to do things differently. How do we do that? We have two main types of big data disaster recovery. First of all, this is storage replication, okay? And the second one is the dual ingestion. Basically, which one you will take will depend on who is in charge of making sure that the data is consistent in the disaster recovery side. On one, it will be the backend. On the other, it will be the front end. Okay. So let's begin examining them. Storage replication. This is similar to the idea that you have in non-big data solutions, that where you just copy the data from one place to the other. You just take the disk, copy everything, voila, you have a working copy of the data on the other side, okay? This is generally implemented by copying the HDFS information from one cluster to the other. Remember, this is not a huge cluster. These are two different clusters, okay? And you need to copy data from one to the other. First of all, you need to take into account that this will take time. I mean, if you're copying several gigabytes of data, this will not get done within seconds. It will probably take some time. So first of all, you need to use this tool, which is the HDFS snapshot. The HDFS snapshot ensures that you have access to a static photograph of the HDFS information stored in your cluster. And therefore, the data stored in there will be consistent. If you just begin copying without doing the snapshot, you may end up with some tables updated. Let's say you have daily batches or hourly batches. You may end up with some tables with a level of information up to date and the others from yesterday. So you don't want that. You just do a snapshot and work on that. And then you use DCP for copying that. Okay, DCP is a tool that basically does a parallel copy between data nodes. So it's very efficient. It uses a lot of throughput, so you can, copy things fast or as fast as possible. But the idea is you take the database, you have your ETLs, you have it stored on the main side, and then you just copy that to the second side. Okay, you have the data. First of all, you have the data, you have like the raw information, but what about the metadata? What about the software? Remember, 2 different clusters. They might be configured differently. They might have, they have their own metastore, so the table information on one side may be different from the other. That is something that you need to take into account and make sure at all times that this is consistent, okay? So you have to be very careful when tracking these changes, okay? Both in software configuration and on metadata. Also, I haven't said so before, but these tools, the HDFS snapshot and the DCP, both work at the directory level, okay? So we're not talking about copying everything every day, okay? Remember, if you have several terabytes of data in your cluster, you don't want to copy everything all times. You will probably resort to something like, okay, we do some daily ingestions, okay, we'll copy just the information from today, or the differences, or you make sure that copy as little as possible. So you need to plan carefully and do some very specific batches that copy data from the initial cluster to the recovery side. And that, of course, poses an administrative overhead, which is important. Despite of this, the solution is quite simple, so it gets used often in many sites. It's the first one that comes to mind. If this is not possible, or if we have something different, let's say that we have continuous ingestion of data into our cluster, then, of course, the first solution might have its shortcomings. You may do a snapshot and then copy, and then do another snapshot as soon as the first one finishes, and do, a copy cycle every time. But of course, it's certainly not optimal. So what is it you need to do? If you have several streams of data flowing into your cluster, probably you're using something like Apache Kafka or any other kind of flow management tool. And you have one on the main side and one on the backup side, of course. What do you do? Just ingest into both. So you just set up the front ends, the clients, depending, of course, on how much can you tamper with the existing infrastructure, but you make sure that instead of writing to one endpoint, they write to both, okay? Therefore, you will have both streams flowing to the 2 clusters, and you will ensure that all information is identical on both sides. Is it? Well, first of all, maybe not. If you leave the task of writing to both endpoints to the application developers, you may find at some point that someone has forgotten that. So you generally set up something like a single endpoint, which would be between the application and the Kafka queue, which is, for example, Apache NiFi or Apache Flume. And you can use that for ensuring that both endpoints get written, okay? And also, it's very important that you have data consistency. You're ingesting information in both ends. Something might go wrong. You may lose connectivity at some point. Okay, you need to ensure that data is identical in both sides. And of course, for that, you need some kind of data monitoring, which already should be in place. You should do this even if you're not doing disaster recovery. You must make sure that your data is consistent, that your data is good. Here, you just have to do that double, okay? And make sure that the results are coincident. Also, you may need to set up some kind of consolidation processes in case the data is different or gets out of sync at some point for any reason. Okay, so the easiest example is just a monthly resync or something like that, but once you get enough confidence, you may not even need to trigger that every time, okay? But basically, and all of you who are parents will know, it's like having two kids. You have to keep an eye on them constantly, make sure that everything is okay, and take action only if needed, okay? What other things can we do? We have these two main types, which are storage replication and dual ingestion. Can we do something simpler? Yes, for sure. We can do this ingestion replication, which is basically, if you already have everything set up as a main site and you just want to build a disaster recovery site, okay, instead of changing all the applications, you can just set up some process or parallel processes, probably one for each queue, that copy data that gets into the first cluster and push that into the second cluster, okay, like a producer-consumer type of role. Of course, you need to make sure that these processes are in place. They need to be monitored as well, but also you need to take into account that they may become a bottleneck, okay? Keep in mind that you're getting, on one data center, a huge ingestion flow for these data streams, and then you have to take those out and into the second cluster. So you need to make sure that, your network can handle all of that. And then, of course, very important, you can have both. Why not have both? Why choose one over the other? Depending on the information that you have, and keep in mind that the dual ingestion works for streams and the storage replication works at the directory level, so you may use different solutions for each. If you have both types of data ingestion, probably they serve different business services, you may set up different things for each as needed, okay? What are the commercial offerings? Up until now, what I've talked about is basically what you can, get out of the box using the current solutions, okay? Using Hadoop, using Kafka in the current versions. But, is there something simpler? For sure, this has already been worked by some vendors, and it would be unfair to end this talk without talking a little bit about them. So first of all, we have the solution from Caldera, the BDR, which is related to the storage replication and basically lets you coordinate quite easily the HDFS snapshots and copies, so you don't have to do that by hand, so that's useful. Second, there's this disk fusion, okay? I must say that I haven't tested it myself, but when I was doing research on the topic for implementing this on some clients, we got the impression that this was quite good. So, if someone has tried it, I will be glad to hear about that in the end. But basically what it does, this solution, is continuous storage replication. It does that by taking a look at low-level HDFS operations, okay? And finally, we have Confluent multi-site, okay? Which is, why have these two Kafkas, each on each site, on each data center, when you can have one Kafka cluster that's multi-site, okay? That's allowed by Confluent solution. So anyway, make sure to take a look at all of these before setting up your disaster recovery, so you may find your path a little bit eased. Okay, so we have a disaster recovery site set up, a cluster there, and we have chosen some solutions for each of the data. What do we do? First of all, the disaster recovery site, since we're building it, does not need to be as expensive as the first one. You're not planning to use it often. This is just for contingency. So you may do some trade-off between capacity and performance and have some higher capacity nodes that have less computing power, and therefore you may be able to store the same information. It will be a little bit slower, but it doesn't matter too much. For example, this is one of the first Google production servers, so it shows that you do not need to spend a lot of high-end hardware for building a valid commercial solution. Very important, okay? I know that this is the one that we text like less, but it's very important to document and test these procedures, okay? Disaster recovery, as I said, it's something that's triggered by a business event or a business person that says, okay, we shall do this right now. And therefore, it means that some people have to come in and take some action. So it's very important that they have everything very clearly defined so that you don't miss the opportunity or you don't do things wrongly and end up with, having no contingency. Also, it will be very important to plan for at least a yearly disaster recovery run. I mean, you want to make it lots of fun, don't warn anybody. Just pick a time, don't warn the techs, and see if it works. Try to do that, of course, with a service that is not too expensive or too important to the company. And also, it's very important, as we said, to keep changes tracked. You need to be very careful that both clusters have the same information at the software level as well, not only because of the data. Also, other uses. You have a very expensive collection of hardware sitting on your disaster recovery site waiting for a disaster to happen. So what can you do with that? First of all, it's very important that you can use it as a backup solution. You're already copying data from the first site, the main site, to the recovery site, so why not keep a copy of that? If you have enough capacity, and remember that we can trade off some capacity for processing power, you can have the backup set up in your disaster recovery site, and then if you need a copy of, let's say, the previous week's information, you can retrieve it from there. Also, you will get at some point to this, some project manager will come and say, hey, I want to test some data. Even though we have development, integration, testing, quality assurance, staging environments, I still need another one. I still need to test this against production data, and the company won't let me do it on the main side. So you have a copy of the production data on the recovery side. Can we test it there? It's difficult to say no, because, as I said, it's a lot of money being just sitting there doing nothing. But be very careful that it may change the data. It may create some temporary tables, it may create something, some aggregates, but you will end up with different information in the recovery side than on the main side. And that you don't want to happen at any cost, okay? And like this invention here, someone will come and say, hey, I have an idea for using the disaster recovery. Just try to put that off as much as you can. So conclusions for this. Basically, you have these three options: high availability, disaster recovery, backup. These have different costs, different impacts. You may need to balance them, so make sure that disaster recovery is only for critical systems. High availability, you may or may not use it. Backup, never skip that. Always have backup. If anybody tells you that you have a good enough solution that you don't need backup, fire him as soon as possible. Make sure that you always have backup. Disaster recovery for big data is different. Why? Because what we said, it's based on hardware. It's a separate set of machines, so it's generally not easily to integrate into the standard disaster recovery solutions. And also, we're talking about data here, big data. And you have lots of data in your cluster, so maybe not all of it has the same importance. So you need to make sure that the important data is safe, that your data is consistent. So always plan for that. Always make sure that the data quality is never compromised. That's the important part here, so make sure about that. Basically, that's it. And I really hope that you never have to use what's being said here about disaster recovery, so hopefully you won't. Thank you very much.